shifting our focus to higher order thinking. For many students who went to school in the 1950s, 1960s, 1970s, and even part of 1980s, our experience in mathematics learning is probably what many people would describe as the traditional approach, where we were asked to do a lot of calculations, including tedious ones, such as multiplying 5-digit numbers by 4-digit numbers. Not difficult, just plain tedious. Also characterized by learning procedures like long division without much understanding as to how the procedure works. And plenty of rote memorizing. Many of us might recall having to spend hours memorizing and chanting the times table. Thankfully, that is now a thing of the past. If our vision of mathematics learning is to be realized. In Singapore, the Ministry of Education have shifted from the so-called traditional approach to one that focuses on higher order thinking starting in 1992. They spent about 10 years in the 1980s through CDIS, Curriculum Development Institute of Singapore, researching and experimenting ways of learning that is more consistent with research and learning theories. And in the 1980s, there's ample of literature to suggest that problem solving must be the focus of school mathematics. For example, in the United States of America, there is a small publication by NCTM called Agenda for Action. And the first bullet point on that agenda is, I quote, problem solving must be the focus of school mathematics. Similarly, in England, there is a much bigger report called the Cockcroft Report in the early 1980s. And in that report, it is mentioned that, and again I quote, problem solving must be at the heart of doing mathematics. With all that in place, Ministry of Education in 1992 introduced a new curriculum framework for mathematics. In that framework, problem solving is right in the middle. Problem solving has been the focus of school mathematics in Singapore since 1992. And today, our students continue to be taught and have a chance to learn mathematics using the same framework, despite several revisions to that curriculum. The Singapore Mathematics Curriculum Framework has remained to be the one with problem solving right in the middle. The shift in emphasis from one that focuses on rote memorizing, from one that focuses on doing procedures without much understanding, and from one where we get students to do a lot of computations, including tedious one by hand. The shift is now to higher order thinking, with mathematical problem solving being the focus. In this framework, skills are still important, but it's not limited to doing calculation. In a Singapore Mathematics Curriculum Framework, there are various other skills that are equally important and given emphasis. For example, visualization skills. Singapore students are today quite familiar with solving problems in a real-world context. In the textbooks that they use, that emphasis is evident. In a national test that they take in secondary 4, that is equivalent to grade 10, there are test items that will require students to handle problems couched in a real-world context. For example, 1 year, they have to figure out the living expenses of a university student from Singapore furthering her study in England. Various information are provided, including a chart, a graph of exchange rates between pounds and Singapore dollars. Also, various other information curated from the real world. And students, during the examination, they have to figure out answers to a range of questions based on the real world context. Singapore students are familiar in solving problems involving the real world context. And that is afforded by the use of calculators in the classroom. Singapore students are encouraged to use calculators in secondary school and in primary school during problem solving. In particular, in upper primary school, they are allowed to use calculators in the problem solving segment of the grade 6, primary 6 national test. And in secondary school, they may use calculators in all the papers during national examination. The use of scientific calculators allow our students to have greater opportunities in solving problems that is based on real-world context. Because information curated from the real world, they are very often messy, unlike the nice, friendly numbers that we can put into mathematics problem that is not obtained from the real-world context. Problems based on the real-world context very often include information that are messy and not so easy to calculate by hand. And the use of calculators allow for inclusion for more of such problems. So it is no wonder that students in Singapore are found to have done well in international comparative studies such as PISA and TIMSS. In particular, in the PISA test, many of the tasks are based on real-world context. For example, a problem based on building a ramp, perhaps for wheelchair users, in a building. In such problem, we kind of know that the height that is fixed, that is the building. There's nothing we can do about that. And the angle of incline of the ramp has to be suitable. You can imagine if the ramp is too steep, that will be problematic for the wheelchair user. So with the angle of incline having to be certain values and the height being fixed, now we need to figure out how much space we might need when we want to build that ramp. So problems such as this allow students to make use of the pure mathematics that they learned in the classroom in chapters on trigonometry to solve problems such as this one. So in PISA tests, there are many problems that are couched in a real-world context. And Singaporean students having opportunities to deal with such problems because they use scientific calculators to deal with the computation, they find this kind of problems not alien to them. So it is not a surprise that they often do quite well in such international comparative studies. Likewise, in TIMSS, Trends in Mathematics and Science Studies, students in the high benchmark, also advanced benchmark, they are the ones who are able to handle complex problems. They are the ones who are able to handle new problems. And they are the ones who are able to explain their thinking. When basic calculation is taken care of, through the use of scientific calculators, teachers have a greater chance to emphasize on such higher order thinking and abilities. And when teachers focuses on solving complex problems, solving novel problems on mathematical communication, that's when our students will find such things doable and they excel in mathematics. In this table, they show the performance of selected education systems in the most recent TIMSS study. We can see that proportion of students in the high and advanced benchmark is somewhat spectacular. Students who are in the high benchmark, they can solve complex problems, and students in the advanced benchmark, they can solve novel problems, but in addition, they can also explain their mathematical thinking. To have more than 80% of a cohort achieving the high benchmark suggests that even average learners, they are fully capable of solving complex problems. And having 80% of a cohort achieving high benchmark also suggests that a significant number of struggling students have reached that level. If you think about a cohort in 3/3, with the bottom 1/3 being 33%, having 80% of a cohort reaching the high benchmark suggests that quite a few of students in the bottom 33% have reached that level. This data is hopeful. It tells us that every student, given the right opportunities, they can do mathematics at the highest level, even those who typically struggle with mathematics. As I always say, mathematical ability is negligibly genetic and predominantly opportunities. When we let them have those opportunities, they will always be able to do it. And scientific calculators provide the chance for tedious computation involving real-world data to be taken out of the hands of the students and allow them to focus on higher order thinking and mathematical communication. With the use of scientific calculators in problem solving, our teachers are more willing to expose students to a greater range of problems. And with those opportunities, you can see quite a lot of them have managed in grade 8 to reach the high benchmark and advanced benchmark. Many people are also worried that when we use scientific calculators, students' basic skills, basic computational skills, basic technical skills in manipulating, say, algebraic expression, those skills will suffer. But as you can see from the data, Singaporean students do not find those difficult. Practically everyone, about 98% of a cohort, are able to reach the low benchmark. Low benchmark requires students to be able to do basic numerical calculation things. And as you can see, despite using calculators in the classroom, by grade 8, the students' ability in basic calculation skills have not suffered.